Mars's similarities to Earth, like water ice and ancient riverbeds, hint at past life. NASA's Perseverance rover explores Mars's geology and climate, offering insights into our solar system. Mars is seen as a potential second home, with manned missions planned by SpaceX. Exploring Mars drives innovations in technology, advancing our capabilities both in space and on Earth. Mars has inspired numerous works of fiction, symbolizing adventure and the unknown. Colonizing Mars is considered a step toward ensuring humanity's long-term survival. Did Mars ever harbor life, and could it still support microbial life today? Mars has conditions that may have supported life billions of years ago, such as evidence of liquid water. Scientists have discovered organic molecules and signs of ancient habitable environments in Gale Crater and other locations. Current missions like the Perseverance rover are searching for biosignatures or direct evidence of past life. Seasonal methane emissions detected by Curiosity suggest active geological or biological processes. How much water exists on Mars and in what forms? Mars's polar ice caps contain vast amounts of water ice. There is also evidence of subsurface ice and possible briny liquid water flows in certain seasons. NASA's Mars Reconnaissance Orbiter detected recurring slope linei, dark streaks that may be caused by flowing briny water. The presence of water is crucial for understanding Mars's climate history and assessing its potential for supporting life. What secrets will future rover missions uncover? Rovers like Spirit, Opportunity, Curiosity, and Perseverance have provided significant insights into Mars's geology and potential habitability. Curiosity found organic molecules and evidence of ancient freshwater lakes. Perseverance is exploring Jezero Crater, believed to be a former lake bed, to collect samples that may contain signs of ancient life. Future missions, including those planned by NASA and the European Space Agency, aim to return Martian samples to Earth for detailed analysis. What is the detailed composition of Mars's surface, and how did it form? Mars's surface is covered with iron oxide, giving it its red color. The planet has a diverse geology with volcanic rocks, sedimentary layers, and surface features shaped by wind and water. Analyzing the mineralogy and chemistry of Martian rocks and soil helps scientists reconstruct the planet's geological history and understand processes like volcanism, erosion, and sediment deposition. Instruments like Curiosity's ChemCam and Perseverance's PIXL provide detailed compositional data. How did Mars lose its thick atmosphere, and can it be restored? Mars's thin atmosphere is composed mostly of carbon dioxide, with traces of nitrogen and argon. It is only about 1% as dense as Earth's atmosphere. The MAVEN mission studies the upper atmosphere and how solar wind stripped it away over billions of years. Understanding atmospheric loss helps explain the planet's climatic changes. Terraforming Mars to restore its atmosphere is a concept explored in science fiction and theoretical studies, involving the release of greenhouse gases to warm the planet. Is there still volcanic activity on Mars? Mars has the largest volcano in the solar system, Olympus Mons, which is about 13.6 miles high. Other significant volcanic features include Tharsis and Elysium regions. While these volcanoes are not currently active, there is evidence suggesting that some volcanic activity may have occurred relatively recently, possibly within the last few million years. Scientists study volcanic rocks and tectonic features to understand Mars's volcanic history and assess if any geothermal activity persists today. Why did Mars lose its magnetic field? Mars once had a global magnetic field generated by a dynamo effect in its core, similar to Earth. However, this magnetic field disappeared billions of years ago. The loss of the magnetic field left Mars's atmosphere vulnerable to solar wind, contributing to its thinning. Understanding why the dynamo stopped helps scientists learn about the planet's internal structure and thermal evolution. Data from orbiters like MAVEN and surface missions help study remnant magnetism in Mars's crust. What causes the seasonal changes on Mars? Mars experiences seasons due to its axial tilt of 25.2 degrees, similar to Earth's tilt. Seasonal changes include the shrinking and growing of polar ice caps, dust storms, and temperature variations. Observing these changes helps scientists understand Martian weather patterns and climate dynamics. What are the origins of Mars's moons, and what do they reveal about the planet? Phobos and Deimos are small, irregularly shaped moons that may be captured asteroids or the result of a giant impact. Phobos is slowly spiraling towards Mars and will eventually break apart or crash into the planet. Studying these moons provides clues about Mars's history and the early solar system. Future missions, such as JAXA's Martian Moons Exploration Mission, aim to return samples from Phobos to Earth. Is there liquid water beneath Mars's surface? Radar data from Mars Express suggest the presence of possible subsurface lakes near the South Pole. These lakes could exist beneath layers of ice and could potentially harbor life. Confirming the presence of subsurface liquid water is a priority for future missions, as it has significant implications for the planet's potential habitability and the possibility of supporting human exploration. Each of these mysteries propels ongoing research and exploration as scientists aim to unlock the secrets of Mars and its potential to support life, past and present. The pursuit of answers to these questions not only advances our knowledge of the Red Planet, but also enhances our understanding of planetary science and the possibilities for future human endeavors in space.